A municipal traffic operations center reviews a cluster of intersections that appear, on paper, to meet all required standards. Signal timing plans are up to date. Lane markings comply with current guidelines. Pedestrian phases are properly allocated, yet the same locations continue to generate a pattern low-speed collisions, irregular congestion peaks, and inconsistent driver behavior that does not align with the design flow. These are not failures of a single component. They are situations where multiple standardized elements, signals, signage, lane priorities interact in ways that create unstable decision points. Each driver approaches with a slightly different interpretation of timing, right-of-way, and acceptable gaps. The system, while technically compliant, produces variation at the moment, where consistency matters most. Within this institutional context, the shift toward roundabouts begins not as a design trend, but as a response to variability. Traffic engineering, particularly in urban and suburban road networks, relies on predictability. The goal is not simply to move vehicles, but to reduce the number of possible conflicting movements at any given point. Traditional intersections, especially those governed by traffic signals, organize movement through sequencing. At one moment, one direction proceeds at another, it stops. This sequencing depends on timing plans that must anticipate demand, adjust to fluctuations, and remain legible to drivers. Approaching from different directions, over time, this creates a layered system of control. Signals, turn arrows, yield signs, lane markings, and sometimes additional signage are all combined to regulate behavior. Each addition is meant to clarify, but the accumulation can introduce cognitive load. Drivers must interpret multiple cues simultaneously, often within a short approach distance. Roundabouts reorganize this structure by removing the need for sequencing altogether. Instead of dividing movement into time-based phases, they establish a continuous flow governed by a single rule yielding upon entry. This shift reduces the number of decision variables. At the critical point of entry, drivers no longer evaluate signal color, arrow direction, and opposing traffic phases. They assess only the availability of a gap in circulating traffic. This simplification is not incidental. It is the result of standardization processes that define how roundabouts are designed, sized, and implemented across jurisdictions. In many countries, transportation authorities develop detailed design manuals that specify geometric dimensions, entry angles, deflection requirements, and visibility constraints. These standards ensure that roundabouts produce consistent behavior, regardless of location. The curvature of the entry forces vehicles to reduce speed. The central island, often raised or visually distinct, reinforces the circular path. Yield lines and signage are positioned to align with driver expectations. Formed through repeated exposure, the effect is not immediate uniformity, but gradual stabilization. As drivers encounter similar configurations across different regions, their responses become more predictable. The system does not rely on real-time instruction, like a changing signal, but on learned interaction with a fixed structure. Institutionally, this shift also changes how traffic performance is measured. Signalized intersections are often evaluated based on delay, how long vehicles wait during red phases. Roundabouts, by contrast, are assessed through capacity and flow continuity. Even when vehicles slow down, they rarely come to a complete stop unless demand exceeds capacity. This alters not only driver experience, but also the operational metrics used by agencies. The adoption process reflects these differences. Early implementations of roundabouts were often limited to specific, context suburban areas, low to moderate traffic volumes, or locations with a history of angle collisions. These initial deployments functioned as controlled introductions, allowing agencies to observe performance under known conditions. Data collected from these sites began to show consistent patterns. The number of severe collisions decreased, particularly those involving right-angle impacts. Vehicle speeds at the point of conflict were lower due to the geometry of the approach. Traffic flow, while sometimes slower in peak conditions, exhibited fewer abrupt stops and starts. As these outcomes were documented, design standards were refined. Guidelines expanded to include multi-lane roundabouts, pedestrian crossings, and integration with existing road networks. Training materials were developed for planners and engineers, ensuring that new projects adhered to established principles. Public communication also became part of the institutional framework, since roundabouts rely on driver behavior shaped by expectation. Rather than explicit control, agencies introduced educational campaigns to align public understanding with the intended operation. Over time, as exposure increased, these efforts became less necessary. The design itself began to carry the instruction. One of the key aspects of this transition is how it addresses conflict points. In a traditional four-way intersection, multiple paths intersect directly. Left turns cross opposing traffic. Right turns may interact with pedestrians or cyclists. Each of these interactions introduces a potential conflict, managed through signals or priority rules. Roundabouts restructure these interactions into a series of merging and diverging movements. Instead of crossing paths at right angles, vehicles enter and exit a circular flow. The number of conflict points is reduced, and those that remain occur at lower speeds and more predictable angles. This transformation is embedded in design standards, ensuring that each new roundabout replicates the same fundamental interaction pattern. The consistency of this pattern is what allows the system to scale. Once standardized, roundabouts can be implemented across different regions without requiring significant adaptation in driver behavior. The same entry rule applies, the same geometric cues guide movement, and the same expectations govern interaction. This does not eliminate all challenges. In high-density urban environments or locations with complex traffic demands, roundabouts must be carefully integrated to avoid capacity constraints. Multi-lane configurations introduce additional considerations, such as lane discipline and signage clarity. These complexities are addressed through further layers of standardization, including lane markings, directional arrows, and sometimes signalization within the roundabout itself. Even in these cases, the underlying principle remains consistent: reduce variability at the point of decision. By structuring movement through geometry rather than timing, over time, this approach has influenced broader transportation policy. Agencies increasingly prioritize designs that produce self-enforcing behavior where the physical environment guides users toward compliant actions, without requiring continuous external control. Roundabouts are one example of this shift, representing a move towards systems that maintain stability through form rather than instruction. The transition from traditional intersections to roundabouts is therefore not a replacement of one object with another, but a reorganization of how traffic is managed at a systemic level. It reflects an institutional preference for designs that minimize ambiguity, standardize interaction, and maintain consistent performance across varying conditions. Today, the presence of roundabouts in both urban and suburban networks illustrates how this stability has been achieved. Drivers approach, slow, yield, and merge in a pattern that repeats across locations. The absence of signals does not create uncertainty. It removes a layer of variability that previously required constant adjustment. The system continues to function not because it eliminates all complexity, but because it concentrates that complexity into a standardized form. Each roundabout, regardless of its specific context, operates within a framework that has been tested, refined, and adopted through institutional processes. In everyday use, this stability becomes less visible. Vehicles enter and exit with minimal interruption. Pedestrians cross at designated points set back from the circulating flow. The interaction, once a site of frequent conflict, becomes a routine sequence shaped by consistent design. The replacement of traditional intersections with roundabouts, then, is not defined by novelty, but by the gradual establishment of a system that reduces variation and sustains predictable behavior over time.